So in this example, okay, hello students, in this example you are going to learn about hardware text search algorithms. So what are the different software search algorithms we have done? So how you are handling with the hardware? So the thing here is, already I discussed about this topic. Whenever you are talking about the hardware, so what is the scalability? How many systems you are going to use? What happens if you are using multiple speeds? And suppose if you are talking search terms simultaneously, what will be the impact on your IO or whatever the impact on your CPU? So in order to overcome all these things, we are using some hardware techniques where you can easily reduce this one. Okay. So what is the another advantage? Suppose if I am making the hardware according to your text search. Okay. So it depends upon your index. Suppose if I create multiple CPUs according to the index. Wow. Imagine how much speed it will be. Okay. So always this hardware text search based on your hardware systems will help to increase your searching techniques and make them optimal. So for example, yeah, so this is your example what we have seen already. So what I'll do here is I'll create one complete system for this. So you'll have the term detector, query resolver and hardware text search unit into a single hardware, and this will be your DB, and this is again user interface which is on another hardware. So what happens then? So it will be very pretty easy in order to communicate, and the speed of this particular thing will be more. So this was the explanation. So it represents hardware as a software, and the automatic part of the system is term detector, and it has three approaches where you can go with the parallel comparators associated with the memory, and cellular structure, and a universal finite state automata, what we have already discussed, right? Now comparator means I'll tell you parallel. What is the difference between parallel comparator and comparator? One comparator, you will share the text and you will get the output. This is one. When I talk the parallel comparator, so the text will be shared parallelly to all the systems and you will get the result simultaneously. Instead of one machine, you are incorporating multiple machines so that you will get the output easily. And next one, when the match occurs, the term comparator informs. So suppose if I am getting the match over here, this has to inform to this comparator and this comparator, because otherwise they will waste the time in checking this. Suppose this comparator got the match first. What it has to do, it has to inform to these two. So this is this thing, and this can be only resolved using your status flags. So this was developed in early 1970s, which can be called as your parallel search. So this was a diagram. So what are the advantages over here? Already we have seen so many advantages, and only the thing is you have to use a special type of operating system, AFP. So this was developed by sophisticated search unit developed this particular thing, and it is capable of searching multiple queries at the same time. And one of the earlier text string search machine was the rapid search machine. So this is one of the machine which is for General Electric, which contains the different documents which can be passed through a single query. Okay. So one more is HSTS, high speed text search. So this was developed by OSI. You know what is your OSI model, which was developed for CN. And next one is how Corasic. So this was defined basically for software finite state machines, and one state of the machine is dedicated for continuous word machines or word phrases. Okay. So this also you can create parallel state machines also. So next type of this one is rapid search machine with GESCAN. So what is a GESCAN? Where you are creating all the complete particular patterns related to the scan algorithm, and you can easily, it will process a complete text array processor, and directly it will store in your secondary storage. And next one is you have TAP, which consists of large cache memory, and it will use 128 query processors. So these are the use cases and real-time examples for your hardware text processors. Okay, so the text will be loaded and searched according to the diagram. So what exactly you are doing here? Yeah, done. So this is a diagram which I want to just let you know. So you'll have all the query processors. These are your query resolvers. If you see here, this is done parallelly. So this is your GESCAN or text array processor. So whenever the term matches happens, so this have to intimate according to the requirements. So query processor will have the two operations. One is it has to give input text and it has to give the Boolean logic resolution. Okay, and it will also contain the series of characters which have to be checked according to the query. And it can also use the external chips called LSI for series of longer strings. Okay, so these are the requirements for your GESCAN system. Suppose for example, yeah, this one was done. So this was a basic example. So just so whenever you are searching this process, you have to remember that each row of the matrix will have the query processor and you will get the chips matched with the query term. So the thing here is whenever suppose 1, 2, 3, 4, 5. So you will have the query here. So this will be sent to this particular linked up parallel processors. So this is a basic thing. Whenever there is a query string, so this have to be sent to all 1 to 5 processes at a time. And this is parallel and this is parallel. So this is a matrix representation of your query processor. So using this hardware support, we can easily optimize the size of the query string exactly, and you can also optimize the speed. Thank you.